recording. There we go. So the recording started, and now I'm going to disappear, Dave. I'm going to turn it over to you.
All righty then. So I'm Dave McDonald. I'm a senior educator at the McAuliffe-Shepard Discovery Center. I teach astronomy and aviation and STEM and math and sometimes computer programming at Belmont High School. And I'm enjoying my time at the Discovery Center. Been there for a long time, was previous education director. And I'm enjoying my time. I'm in my 9th year teaching at Belmont High School. And so welcome tonight. And I hope that you enjoy this. I'm going to start with kind of a PowerPoint presentation and talk about some things. And then I'm going to manipulate my screen. So it's not like seamless. I'm going to probably have to stop PowerPoint and go to my screen to get on the internet and all that kind of stuff. But hopefully the idea is that when we're done, you'll have enough information to go play and figure stuff out yourself. Because, you know, computer programming, you know, we would need 5, 6, 8, 10 hours to, you know, for me to teach and practice, and you're in the classroom and you have your computer open and I show you do this and you do that. So we don't have that environment here. So I'm hopefully going to show you enough stuff that will be interesting, something to learn about programming, something to learn specifically about Scratch. And then you'll be able to connect to Scratch yourself, look at tutorials, experiment, and have fun. Scratch is a very powerful language to learn, but it's very visually oriented. So it's a good beginner language. So that's why I chose it for tonight. So I hope that you'll enjoy the presentation. So I'm going to begin by sharing my screen and see if this is going to work. Okay, so here we are. Okay, so my email is astromannh@gmail.com if you'd like to get in touch. All right, so next, I want to open with this is where I got the title for the presentation tonight, and I'm going to read it together with us. We need to support and maintain programming and coding in all our schools, not just our technical high schools or institutions of higher education. And we need to teach computer literacy for more reasons than innovation and consumerism. Programming requires critical thinking and math skills and communication skills and problem solving and creativity, and trust me, perseverance. These are all the things that companies can't get enough of these days when they're looking for new talent, new employees. And this is an excerpt from Edutopia, Program or Be Programmed by Mary Beth Hertz. And she gave me the inspiration for the title. All right, what are computers good at? Well, computers are good at math. They can do things fast. Computers can do repeat operations and not get tired or bored. They can look up information quickly. They can make decisions based on rules that the human programmers establish and put in place. And computers can represent things graphically, throw some numbers up there, some concepts, and look at a graph, look at an image, look at a picture. So computer programming is fun, and there's going to be no shortage, or there is and won't be any shortage of jobs, because every time you look around, something else, even your refrigerator is computerized. You go to get soda at many places, whether it's Five Guys or Wendy's, Burger King, and oftentimes you have this big unit and you have this touch screen there. Well, it's a computer. And as a matter of fact, I will tell you, one of my former computer students initiated the code for the first models of that type of machine. And I'm sure there are other companies doing it now also. So a quick overview of the types of programs, two main types, one linear or top to bottom programming, where you have a line of code and then we do the next line, and the next. It just goes from top to bottom sequentially. And then we have branching, where conditions determine what gets done next. So it's like we do this, we do this, we do this, and now there's a decision. Are we going to go left or right? Are we going to do this thing or that thing? And so branching, and that's decision structures. And then repetition, loops. It's a series of steps that just need to be repeated over and over again. And you just need a condition, which we'll talk about in a little bit, a condition on when to exit the program. So we're going to be talking about, let me just go back for a second. Okay. So we're going to be talking about Scratch, and Scratch is scratch.mit.edu. So it's really easy to remember, scratch.mit.edu. And I'll mention that again down the road. So these are the various categories of commands, and they're outlined very nicely, and I'm going to show them to you in a little bit. If you have a computer on the side, you can go to scratch.mit.edu. But we're going to talk about motion, looks, sounds. I'm going to mention that to you. I'm not going to do a lot with sounds. Events are important. And then we have control, sensing, operation, operators, variables, and you can customize blocks that are like yours. So if there's a series of things that you do frequently, or if you're involved in a larger program and there's a set of commands that you do over and over again, it's almost like in a sense, like a copy and paste type of thing. All right, so those are the main things. There's tutorials, which I'm going to mention, because again, I'm going to give you an overview of the power or the things that Scratch can do and how it works. You're not going to be a pro when you leave this time together, but you should have the tools to make yourself a pro. And again, over to the right is the website scratch.mit.edu, and we'll take a look at that. All right. So I'm going to bring up the screen in a moment, and these are three things. The two major ones are choose your sprites. Well, what are sprites? Sprites have costumes. Sprites are like the main actors. They're like the main characters on the stage. And the stage is, you can choose a background. You can choose your own background to be the stage. And I'm going to show that to you now. So I'm going to stop the PowerPoint. We'll come back to here in a little bit, but I want to break away and show you what I mean by what sprites are and choosing your background. And then we'll get into the commands and how you interlock things together to create a program. Okay, so give me a moment, and I'm going to stop sharing this, and I'm going to go back to share my screen. And I think what I'm going to do is just share my screen. I think that'll work. I think. Okay, and so I want to hang on a moment. I want to end that show, and put that to bed for a moment. And then I need to, of course, the things that I need are hiding. That's interesting. I'm trying to get to something that's being blocked. Interesting. All right, I'll try one of these over here. All right, that's not working. I know you can see my whole screen, but right under where it says I'm sharing my screen, I need to get under there. And I can't. There. Okay. There we are. Okay, so you can see my screen, I trust. And over to the left, we're going to talk about in a little bit. I'm going to go through each one of these items over here. There's a lot of stuff there. I'm going to break it down for you so it's simpler. And the categories are way on the left with these like colored round circle buttons, if you will. Okay. Now, in the bottom middle of the page are tutorials, and it tells you that tutorials, and so you can play obviously
with Scratch. You can make your own stories, games, and animations. Let's start by grabbing a move block. We can click the block to run it. There are many other blocks to choose from. Check out the different categories. Let's go to the sound category and grab a play sound until done block. I'll snap this onto our move block. When do we want these code blocks to run? Add an event block on top to start the code. I'll add the when green flag clicked block. You can easily reorder or delete these blocks at any time. Add as many characters as you want to your project and code each one. Check out the tutorials page for ideas and inspiration.
Okay, a quick tutorial right there. We're going to unpack what you just saw a little bit. But now look with me over to the right side of the screen, and you can see the background is like a galaxy. It's a picture, a Hubble picture. And you can see there's a little cat in the middle. And the cat is a sprite. The cat is the actor on the stage, and the stage at the moment has a background of a galaxy. I'm going to show you how you can choose sprites, and you can use programs that have multiple sprites. And I have some samples that I'm going to show you in a little bit. Okay, so if I look down here at the bottom, can you see my pointer? Pretty much the bottom right of the screen, where there's a plus sign, says choose a sprite. So I click on that, and these are all the different kinds of sprites that I have. Again, they're the main actors on the stage that can do things that are part of whatever it is you're doing, or they can be the ones that simply tell you answers and such. And so I have dancers. So look at this one that I just chose, Anina dance. You can see this motion going on there. And each one of those motions is, is called a costume. So you can choose, if you like one of those motions that you would like to use, you can use it, you can change it, you can have it change on its own, just like you see happening. I've moved down to the bat sprite, and you can see the bat has, I think, looks like 3 different positions, and you can choose any one of those, and you can change from one to the other, and those are called costumes. You can see at the top here, you can categorize them if you want. So there's all the animals, which includes bugs. There's different kinds of people doing different things. Fantasyland, there's a bunch. Dancing, which has a lot of moves, like here's the Champ 99 in the middle guy. Music, various instruments, a microphone. Sports, look at Jamal in the middle, putting on some moves there. Food, The birthday cake is jumping up and down. Cheesy puffs are not doing anything. The glass of water is empty and full. Then you have some fashion here, and glasses, different types of glasses that you could wear. And letters, you can spell things, and you can do various things with letters and numbers. So those are the sprites, and the one that is, so to speak, the default sprite is the cat. See, if you see my pointer down towards the bottom right, you see the trash can with the X, and that's typical symbol for delete. You don't have to, the cat sprite automatically shows up, and you can add other sprites. And so we'll add another one. And if you want, I'm not going to delete the cat, but you could delete the cat if you wanted to. So my nephew likes dinosaurs, so I'm just going to choose the dinosaur. So you can see I've got the cat and the dinosaur there on the stage. So if I want to change the background, then in the way bottom right is choose a backdrop. So right now I have the galaxy, but which you can see is here. And again, there's a variety of different categories that you can go to if you like fantasy, lands, music. So again, these are backgrounds. These are like your stages. So you can see there's a concert, spotlight, theater ideas. For background for sports, you've got a couple of baseball diamonds, a soccer field, a couple of theirs, a playing field, generic, basketball. You want to be outdoors, on the farm, on a boardwalk, at a pool, at a school. So variety of things indoors as well. Space. And again, right now we got the galaxy up, but we can change that to the moon. So you see now I have my sprites on the moon. So that's kind of the way that works. So you get your main players that are going to be doing the main actions for you. In this case, I have the sprite and the dinosaur. And if I click on them, you can see there's no code like in the middle part. It's all white. And if I go to sprite with the cat, I wrote a little code that we're going to get to in a moment. Okay. So I think I can hang out here, I think, and just go ahead with the presentation. All right, hopefully that will work out okay. So we're going to choose our sprites, then we're going to choose a background, and you can customize. Like if you want to take a photo, if you want to draw something yourself, or you want to like draw something or somebody with like 3 or 4 different actions or positions, you can do that. You can create your own sprite with its own costumes. And you want to take a picture of your backyard, you want to take a picture of your school, you can, and you can use that image as a backdrop. So it's very, creative is a key word for Scratch. It's awesome. So you've got these sprites, and you can cause them to move around. So you can, we'll just go through these bullet points here. So you can move so many steps. You can turn so many degrees, right? 360 degrees in a circle. You can go to a certain position on the stage. So this is important. There's 480 across, okay? From right to left, there's 480 steps or positions or pixels, if you will. 240 of them are negative and 240 of them are positive, which includes 0, right? So if you want to be at 0, that's the center of the stage. If you want to go to the left, you use negative numbers down to negative 240. If you want to move from center To the right, you use positive numbers up to 240. And then you have the y-axis, which is vertical, up and down. Again, the center of the stage would be y equals 0. And you have 360 positions. 180 of them are positive, which includes 0. And 180 of them are negative. So if you wanted to be in the bottom left of your stage, it would be minus 240 minus 180. Then the next bullet point here, you can point your sprite in any direction. You can have them straight ahead, again, 360 degrees in a circle. So you can point your sprite diagonally up, backwards, or however you would like. And then you can move your sprite. So the top one again is move so many steps. But down here, where my pointer is, third from the bottom, you can change from wherever you are. You can change X or Y by however many steps you want to. You can also make it move in random directions. So if you want to make a game, or you want to make some kind of a guessing thing, or you're just interested in making something pretty that's randomized, you can random. And then this is an interesting piece of the moving, because if you have it moving in a certain direction and it gets to the edge of the screen, or it gets to the edge of the stage, you can have it bounce, which means it's going to hit the stage and come back, whether it's the top or the bottom or the left or the right. If on edge, then it can bounce. So that's kind of cool. We'll show you these things in a moment. So let's look at moving the sprite around. Okay, so let's see if I can put this back to bed for a moment, and then we're going to come up here and see if we can move the sprite, which of course we can. So at the moment, I'm going to just save. I'm just moving that. I'm just clicking and dragging. That's something I want to show you later. I'm just going to put that off to the side, and we're going to move the sprite around. Okay, and let's see. I need to move my head out of the way from what I'm looking at here. And you can see motion. That's the blue stuff is the motion. And right now I have the sprite cat chosen. So I can move it. So see, if I take this go to, I'm just holding it and dragging it over here. Okay. Now something that you'll learn in a little bit is the what we call the events. And the first event is when clicked. So I'm putting that in the top. See, they just fit like puzzles. And so that means when I click that, this is going to happen. So again, I have my cat sprite chosen, and I'm going to have the cat go to X minus 200, which is over towards the left. It's not all the way. And then Y, I'm going to go minus 100. So we're talking about towards the lower left of the screen. Okay, when that is clicked. And I never mind. Okay, so that's where they're going to go. And then after they're in that position, I can have them, this is another thing in terms of control, I can have him wait there, okay, which is a control of time. So wait there for how many seconds? Well, let's not take too long. So we're going to move there. We're going to wait 2 seconds. Let's go back to the motion. And then let's turn 15 degrees. Let's move that over. And this can be any number to 360. the numbers conveniently come in 15s. So I'm turning 15 degrees. I can click on it right there and change it to 30 if I would like to, turn 30 degrees. And then from 30 degrees, I can say glide. And this is kind of a cool thing. So instead of like just appearing there, I can glide in 3 seconds to a specific position, like where the mouse pointer is. So notice this, or to where the dinosaur is located. So I'm going to click to the dinosaur. Okay. So that's just, you can drop and move these things around. So let's just see what happens if I click this flag here. You see that he has moved and he turned 30 degrees and he moved to where the dinosaur is. Well, I can go to where the dinosaur, so now I've clicked on the dinosaur sprite down in the bottom right, and now I can do some motion there, and I can determine, well, where do I want the dinosaur to be? Right now, the dinosaur is located at 83 and 34. Right? So let's bring that over. We'll tell the dinosaur where to go. And then let's have the dinosaur turn to the right. And let's go to the right. Have them go to the bottom of the screen. So let's say 90 degrees. We're going to turn 90 degrees. And we are going to glide here. We're going to take 2 seconds and we're going to glide to a position that's kind of low, but kind of on that side of the screen. So why don't we say positive 200? And then the Y value, let's say, will be negative 100. And that will happen events when clicked, we'll put here. Okay. So when I click it, there goes the dinosaur down to the bottom right corner, right? He turned 90 degrees and it took 2 seconds and he went down to position 200, negative 100. So the dinosaur is down there. If I go back to the sprite over here and click this, the cat is going to go back to the bottom left corner because that's where I said to go to. Wait 2 seconds, turn 30 degrees, and it's going to glide to dinosaur 2. So there he is, 2 seconds. So the turning is not the direction it's going to be going. The turning is how the sprite is oriented. Okay. And so notice, I'll just play that one more time. So you see the cat is turned and then slides in the direction, in this case, to the dinosaur. So that's just a little bit about movement. You can move to places, you can turn degrees, you can go, you can point in. So if you look down here with me on the bottom, on the left side, point in a direction, point towards the mouse pointer. So you can determine where things are going with your mouse pointer. So that's kind of cool. All right. So I'm going to come back to my PowerPoint slide, and we'll come back and play a little bit with this. So let's get back to here. So take a look. We did. All right. So you want to put something in, and I'm just going to take a little drink here. So in the look category, 2 major things happen in the look category. One is this is where you get to say things, and it's also where you get to change costumes. We have a lot to do in the about a half an hour or so left. So I'll let you play with the switch costumes piece, but it's important to know I can put stuff in and I can get stuff out. How do I get stuff out? Well, under looks, you can say hello for 2 seconds. You can say whatever it is you want. Say hello. You can think. I'm going to illustrate this in a moment. The sounds, you heard some sounds earlier. I'm going to play some sounds and a couple of sample programs that I put together. So I'm going to let you play with the sounds. We just don't have time to do every single thing, but scratch.mit.edu and you can play with the sounds. The event that I already showed you, this is really important. When the green flag is clicked, things happen. So you can click on the green flag that's above a particular piece of code that you've put together, or maybe you noticed above the stage, there's also a green flag up there, which means everything that you've coded will play at the same time. Then you can cause things to happen when some key is pressed, like the space bar. So if you want something to happen when you push the space bar, there's a code for it, or any other key that you like. Or when you click on the sprite itself, it will do something. So those are some key events that you can choose. The control, wait a time. You have it do something and then you want it to wait, because if you don't wait for certain things, they happen like all at once, and it's like, well, I thought it was going to go from here to here. Well, it did, but you didn't give it time for you to actually see what was happening. It just all happened like that. So you can put in wait however many seconds you want. There might be things that you want to repeat. So you can say, in this instance, in this example, repeat 10 times. And what are you going to repeat 10 times? Whatever the blocks are that you put in the middle. Whatever you put in the middle here will repeat 10 times, or however many times you want, whether it's twice or 100 times. Forever, that's what it means. It's a continuous loop that's going to continue to do things. Now, so far, we've pretty much talked about linear programming from top to bottom. One of the powers of computer programming is making decisions. So under the control section, you have an opportunity to decide some things and what happens. So if a condition, and there will be shapes that you could put in here, if something is true, then do these things that are in the middle, which can be one thing, it could be 10 things, could be 100 things, but that's poor programming. Then you see, if this is true, then do this, but otherwise, if it's not true, if this is not true, then do this. That's called if, then, else. Or wait until something happens. Don't do the next thing until something happens. And then you have another loop control, repeat until. So whatever you put in here, which again can be one command, it could be 10, 20 commands in there, but it's going to continue to loop around and repeat until some condition is true. And then after certain things happen, if you want to stop everything, say, okay, program's over, we're all happy. Then over to the right, you see stop all. And there's a drop down menu, which doesn't work because this is a, an image on a PowerPoint. So the drop down doesn't work right here. But you can stop sprites, you can stop only one sprite from acting, you can stop all sprites from acting. There are a few choices under the stop menu. So how do you put information into a program? So the key one is over here on the left side, ask. what's your name, for example, and wait, and then you get an answer. Other input is by sensing. So if you look over under the sensing, if something is touching the mouse pointer, so I can use my mouse pointer like in a game or something. And if something is touching the mouse pointer, something's going to happen. If something is touching a color, and there's a color palette to choose from, or there's the dropper icon, so you can go to wherever on your stage or your sprite and get the exact color you want and put it there. Do something. If one color is touching another color, then do something. And you can set a distance to wherever, the mouse pointer, for example. So this stuff comes into play when you make some simple games, which I'm going to show you in a little bit. Okay, but a key input is ask. What do you want to put in? What's the answer? And you can put that answer into another thing like this. For example, I'm going to say, what's your name? And it's going to wait until you answer the question. And then the answer is going to be here. And then you get output by using looks. So you can say hello for 2 seconds, say hello, think. But what you can do, look down in the bottom right, and you ask, what's your name? And wait. So you're going to type in your name, and then you're going to take that answer block and move it here. So instead of say hello, you're going to say answer for whatever period of time you want, in this case, 4 seconds. Okay, so let's just go do that. So I'm going to get out of this and go back to here. So look over on the right side, sorry, the left side. And this is the program for the cat sprite. I just need to move keep moving my little image out of the way. So look over here that I'm circling. All right. So when clicked, it's going to ask, and who's going to ask? Well, it's the cat sprite that's going to ask. Right now, he's hiding underneath the dinosaur. So we need to get him out of there. So what I'm going to do is see this right here. Well, you know what? I'm not going to do that. I am going to go over here and go to. So before I ask the name, see how easy it is just to click things in here. So I'm going to click that in there. So the sprite is going to go to -200, -100. And then the cat sprite is going to ask the question, what's your name? And wait, I'll type it in. And then say hello for 2 seconds, but we're going to say the answer. Okay, so what I'm going to do then is take the just scrolling down. Where did it go? I'm asking the question. All right. So here I'm going to take answer from here and slide over and say hello for 2 seconds. And then the say answer is redundant. So anyway, let's click on this and see what happens. So first, oh, sorry. Let's see over here, the red stop sign, that stops everything. So this was supposed to be a -200, not a +200. So that's why it didn't move. There we go. So go to -200, -100. There we go. And he's saying, what's your name? And so I'll type in my name, David, and I can click on the check mark over here with my mouse, or I can hit the enter key, and then it's going to say David. So I put input in and it spit it out what I asked it to, and I asked it to say my name, and it did. And again, I'm not going to take time right now, but I can play with the motion because remember we had the cat turn, and we can turn him back right side up if we would like to do that. Okay, so there's a piece there. Righty. So there's an input output example. Input by ask whatever it is you want. I have some examples I'll show you in a little bit. So you can do math. These are just some of the things you can do. You can add things together. You can subtract, multiply, divide, of course. I mentioned in the description about probability, about what are the chances of. Well, you can pick a random number. You want to practice rolling the dice, pick a random number from 1 to 6. Do it 100 times. Count how many times does a 1 come up? How many times does a 2 come up? Or more interesting, because that should be about the same. Or more interesting, roll 2 dice, right? And pick a random number from 1 to 6, and then pick another random number from 1 to 6. What's the sum of the 2 random numbers from 1 to 6? And if you do that 100 times, and the nice thing again about a computer, it can do it 1,000 times easily, relatively quickly. And you will notice that lucky 7 comes out the most, 12 comes out the least, 2 comes out the least, or 12 and 2 come out basically the same. So you can have probability fun. You can get an answer. Is it greater than anything? Doesn't have to be 50. If some number is greater than some other number, then do something. If it's less than some number, do something. If an answer is equal to something, then do something. And you can create variables. And again, this really is getting into a little deeper parts of programming, so that you need to spend a little time if you're not comfortable with variables. It's a number, I should say, a representation, typically a letter or a word, like the word sum, for example, SUM, is a variable that could represent like N1 plus N2 equals the sum, that type of thing. And you can change the variable. You can increment it. You can show it. You can hide it. And we're going to have a look at some programs now. Several programs I'm going to show you. Again, you're not going to probably understand all the ins and outs of all the code that's there, but I just want to show you the power of some of the things that Scratch can do. And then you can play, do the tutorials, and just, it's so easy just to play around with and create things that you can just have some fun with. So I'm going to, we'll get back to that in a moment. And so one of the things that you can do is I have, let's see, I want to see if I can find another Scratch here. Okay. And I'm going to, up here, you see where my pointer is under File. I'm going to click on that, load from your computer. So I have some Scratch programs. So when you do a Scratch program, you can save it to your computer. And you'll find that when you go to scratch.mit.edu, you can make an account. It's free, but you can store stuff there. You can share things. You can look at other people's stuff. It's a great learning environment. And I think I'm giving you enough so that you can go and explore and create and have fun yourself. So I'm going to click on load from computer, and I'm going to click on Pong here. So this is a Pong game. And notice I have two sprites. I have the paddle, which is this blue item, and I have a ball. So this is the code for the paddle. It's going to start, it's going to go to 0, x, which is in the middle, and negative 160, which is very close to the bottom. And then it's going to set x, the x value, to the mouse. So wherever my mouse is, that's going to be the x value of the paddle. So I can move the paddle with my mouse. Let me click on the ball sprite, and the ball is going to go to 0, 160. It's going to point in a random direction somewhere between 135 degrees and 225 degrees. And it's going to move 12 steps. And if it hits the edge of the screen or the edge of the stage, it's going to bounce. And if it touches the color pink, then it stops. Now, I'm not going to take time to fix it now, but you may notice there's a little bit of a gap between the paddle and the pink. So sometimes, even though it looks like the ball hits the paddle, it went through and hits the pink, and it stops. But I don't have time to fix that right now. If it touches the paddle, then point in a direction, a random number from negative 30 to positive 30 degrees, and play a sound. Play the pop sound. And there's a whole lot of sounds that you can play. You can record your own sounds. So enough said. So I'm going to click on the green over here, right? You see in the upper right above the stage, I'm going to click on go. And then I'm going to hopefully quickly get my mouse down to the paddle. Go. See, I wasn't fast enough. You can slow the ball down. All right. So I'm going to click on begin, and so I'm playing Pong. And if my paddle's not there, the game ends. So simple game. It's kind of fun. Let's see. Next, let's load another program focused on numbers. So I'm a math teacher, and you may or may not have heard of the Fibonacci series of numbers, but I have a program that I wrote that figures out the Fibonacci series. And so I have chosen flowers over to the right as my background. And I've got this Italian, I think he kind of looks Italian to me, Italian guy, because Fibonacci was Italian. He was from the realm of pizza. And so you can look at this, and I'm not going to go through every line because we don't have time, but you can see, okay, so the sprite, Jamie, is going to go to the bottom left corner, which is where he is. And he's going to say something. He's going to ask how many Fibonacci numbers I would like. And then there's a calculator. You see there's some math going on here. Over on the left side, these are variables that I have set up in the program. I have a counter, I have an F1, an F2, a number F, and a sum. These are variables that I need to accomplish the program. So I'm going to just click on the green flag, go. Hello, Fibonacci numbers can be found in flowers, and they can. How many Fibonacci numbers would you like to calculate from 1 to 10? I'm going to say, let's do 9. Okay, and I could hit enter, or I can mouse click on the check mark. And so it's going to go through and show me them, 0, 1, and 1 again, because 0 and 1 is 1, then 1 and 2. The next one will be 3. 3 and 2 is 5. 5 and 3 is 8. 8 and 5 is 13. Then 13 and 8 is 21. And the 9th Fibonacci number is 21. So a math program. So that's kind of cool. And then load from my computer. Let's see. Oh, this one is fun. This one is, yeah. So this has 3 different sprites, and I wrote some comments down here. So I have, I'll center this a little more so you can see. So this is a script to fly the bird, moving the bird. This is a script to play the bird sound here. Then I have a sprite called the duck. So if I click on the duck, there's my duck, which is moves, and then next costume. So the next costume is going to make it look like it's flying, right? Add a script to move the duck while switching costumes to pick up and eat fish from the lake. Then we have the duck sound, and then I have the seal over there, and the seal is going to move around, and I have a script to play the sea lion sound. So this is a little noisy because you've got a bird, a duck, and a seal all making noise. But watch over on the right on the stage. And again, the background I chose was what I thought will look good, is kind of an ocean with a beach. So watch and listen what this does with 3 sprites. If you click on the individual flags, it will just do that one part of the program. Clicking on the green flag over here, they all run at the same time. So and so you can see where changing costumes comes into play or value, because it looks like the bird is flying. It looks like the duck doesn't, I don't think it's a good looking duck, but anyway, the duck is like tossing the fish up in the air and catching it, and such. And then you can have fun with moving stuff around. So there's 3 sprites happening at the same time. Let's go back to file here and load from my computer. What's another good one I have? All right, so here's another math one. So this will be pretty quick. And then, yeah, so let's do this one. So this is finding the hypotenuse of a triangle. Okay, so a little math here. I can show these values. So this will help me debug a program. If I see, well, are the values that I'm calculating correct? Because if you look over on the far left over here, I have my variables that I'm using in the program to find the hypotenuse. So you can look here, set is the command to set a variable equal to something. So I've got an answer. I'm multiplying leg 1 times leg 2, leg 1 times leg 1, which squares it, leg 2 times leg 2, which squares it. And then I'm summing them, adding the squares together, and then I'm finding the square root of that sum to find the hypotenuse. And then I'm going to say the hypotenuse of the right triangle is, and then next costume, you'll see the wizard change, and we'll have an answer for 5 seconds. So I'm just, so you know it works, I'm going to use the standard numbers, the 3, 4, 5 triangle, and then I'll do it again with something maybe more interesting that we'll just try. So if I say go, what is the first leg of your right triangle? So I'm going to say 3, enter. What is the second leg of your right triangle? I'm going to say 4. And we know the answer to the hypotenuse is going to be 5. The hypotenuse of your right triangle is, notice he moved, 5. Let's do it again. We'll just make up some other numbers. So we can use some bigger numbers. So we'll have leg 1 be 56. And the other leg of the triangle will be 74. And what's the hypotenuse? It's going to be more than, it's got to be more than 74, right? Because the hypotenuse of a right triangle is the longest side. So let's see what it's going to be. The hypotenuse is 92.80. So there's some math homework done for you. And let me click on file, load from your computer. And let's see, I think there's the one more that I wanted to show you. Yeah, whack-a-mole. This one's pretty complex, but it gives you an idea of some of the things that you can do. And I'm not good at playing it. I wrote it, but I can't play it so well. So this has got one sprite, but the background has some things going on with it. And it has subroutines involved, which is, I just want to show you this. It's a little on the complex side, like I said, but just to give you an idea of some of the fun things that you can work up to. And so, you know, when it says, when I receive a message, so it's like when something happens, this section here will play, so to speak. So again, I'm not good at this, but the good thing is, I think it maxes out at 10 or 10 misses, right? So I'm going to click the green screen, go, moving using signs. So if I miss, it's one sound. If I hit it in time, I win. I have, whenever you get, whichever you get to 10, whether it's the hits or the misses, that's when the game is programmed to stop. You can go on more, obviously, if you want, but I hit 10 times and missed only 4 times. So, you know, that's kind of a fun game. And you can make a variety of things. So I hope I've given you some way to look at programming and the things you can do and such. And I would add here, I want to just put this in. I've said it a number of times, but I just want to write it down here once again for you. Scratch.mit.edu. Okay, and that's where you go to have fun. Scratch.mit.edu. And I believe, yeah. And that's it. I'm going to open up a chat, and you can unmute yourself. If you have some questions, I can go back and review some slides or just answer some questions for you. So I cannot read any of the writing on my screen. This is the second computer. I try to check this on. Everything is the same. Nothing I can read. Okay. I don't know why you can't see things. Who can see a message? All right. So I'm sorry. I don't know. Did anybody else have a problem showing? I'm going to stop sharing my screen and come back to everybody. And let's just see who's there. Okay. So yeah. All right. Any questions? Anybody wants to unmute and ask? You certainly can. Or if you want to write a Q&A, you could do that as well. So your choice. Okay. Looking for any Q&As. Okay, I see Adam and Alan, Krista, Corey, Eleanor, Kristen, Mary, Suzanne, and there's a couple others. So, any thoughts, comments? Was this helpful, inspiring, not so good? A little feedback, anybody? And it's fine, be honest. You can unmute if you like. All right, so that's good. I'm glad that you enjoyed it. And again, I hope I gave everybody just enough to scratch the surface so you can explore yourself. It's a lot of fun, and it's good for the mind, and it's good for young people because, like I said before, programming is not going away. Any other thoughts? Glad you found it interesting. Would I be willing to share my demo program? The answer is yes. I certainly could. So if you email Mirka, or you could email me, I can put my email address back. It's astromannh@gmail.com, and I'm very happy. The nice thing about Scratch programs is they're small files. They don't take up much room at all. And so you get into Scratch on scratch.mit.edu. I send the files to you. You put them in your computer, and then you just download them from your computer, and they should work. And you can play around with them. You can edit them. You can make the whack-a-mole program easier or harder. You can play with the programs, which is nice. Okay, so I think I'm done. And if you have any parting questions that you want to ask, you can. Let me put, if you don't mind, let me just go back quickly to here. And hang on just a second, please. So I can just share that one more time with you, and then. All right, so I'll put this up for just here so you can see the screen there. My email, astromannh@gmail.com, and if you write to me there and request, maybe have some comments about the program, what was good, what could be better, or request some of the files. And if there's one in particular that you want, or if you like several of them, all of them, happy to share. Okay, astromannh@gmail.com. And I think that's it on my end. Oh, well, thank you for your kind comments. I appreciate that a lot. Okay, so we're 8:07. I think that's a good amount of time. I had fun sharing it with you. I hope you had fun, and you get to go play, right? Scratch.mit.edu. Okay. So I think that's it. Bye-bye. Have a good rest of your evening, and feel free to email me anytime. Okay, we're gonna close the meeting. Okay, bye-bye. You're welcome. Bye-bye. And you can let Mirka know, your comment. I think she sends out a survey also. And Corey, thank you. How different is this from Delphi? I don't know. I have to be honest, I'm not familiar myself with Delphi. So sorry, I can't help you with that question. Anything else? Anybody? All right, I think that's it. Bye-bye. Have a great rest of your evening.